Good morning, good afternoon, good evening, depending on when you're watching this. It's your boy, Mr. Malachi, and I'll be taking you through this next video on quadratic inequalities. So, what are inequalities? You would have learned this in grade 10 or grade 8 and 9. And those are just these equations that have greater than or less than signs. Sometimes there's an equal to sign in there. So that's what inequalities are. But in this level, we're going to be solving quadratic ones. So let's take one example. Let's jump straight into it. What if we have an x squared that is subtracting a 4x that is being added by a 3, and you're told that this guy is less than 0? How do you solve this? So firstly, we're going to factorize it as though we were factorizing a normal quadratic equation. We're going to open our brackets. We still have our less than 0 there. Factors of positive 3 that add to give me a negative 4 is a negative 3 and a negative 1, right? So we factorize it. Now we can find our critical values. So that CV there stands for critical values. And so what our critical values are is that x is equal to a positive 3, right? And then in this case, x is equal to a positive 1. I hope you see how I'm getting those values there. Then now we've gotten our critical values, we need to decide from the sketch. So you always need to sketch this, because without the sketch you can't actually tell how it needs to look. So we have our positive 1 there, and we have our positive 3, right? And then how are we going to draw a parabola? That number in front there tells us our parabola should be a smiley face, the fact that it's a positive number. So parabola looks like this. It's facing up because that a value is positive, so a is positive. That's why we have the smiley face. And then we need to look at this guy. So that guy tells me that in your parabola, we are looking for values below the x-axis. So this, remember, is our x-axis. So if it says less than, it's telling me that we are looking below the x-axis. And if you look below the x-axis, the range of x values are between 1 and a positive 3. So how do we write that as our final answer? We say that x is greater than a positive 1, but it's less than a positive 3. And that's our final answer. All right, I hope that makes sense. Again, let me highlight how we draw our graph. We first look at this a value that x squared has. If it's positive, then it tells me my parabola will be a smiley face. So if a is positive, it's a smiley face, right? It's curving upwards, right? And then what else do we look at? We look at this sign here. If it says less than, that means we need to look below the x-axis. If it had said greater than, then we'd look above the x-axis. So below the x-axis, where is our graph? It's between 1 and a positive 3. And so we write that as a range, and this is our range. I hope that makes sense. Let's try the next one. What if we're given a 3x squared minus a 2x all less than a positive 1? Again, we need to rearrange this so we get it in standard form. So we rearrange it, we bring the 1 over, it's going to be a minus 1. And we have it looking like that. Then we factorize this. This is quite easy to factorize. The way I factorize these guys is I take the 3, I times it across like that. I'll get an x squared minus a 2x minus a 3, right? And then I factorize this guy. factors of a negative 3 that add to give me a negative 2 is a negative 3 and a positive 1. But just as much as I multiply with the 3, I need to come back and divide the factors with the same 3. So I end up with these brackets here. I end up with an x minus 1 in one of the brackets. In the other bracket, I can leave it as an x plus 1 over 3. So this is how it looks factorized. So now that I've factorized it, let me get my critical values. My critical values for this first bracket will be x is equal to a positive 1. My critical value for the second bracket will be that x is equal to a negative a third. All right, now that I've gotten my critical values, I need to decide how my plot looks. So let me plot it here on the side. There's my x-axis. So where am I plotting? I'm plotting at negative a third and at positive 1. So how does my graph look? The A there is positive, so it tells me it's going to be a smiley face like that. It's going to be pointing upwards. A is positive, it's a smiley face. All right, I've established how my graph looks. Now I need to check which side am I looking. It says it's below, it's less than 0. So less than 0 is going to be below your x-axis. And so how do I represent that as a range? That means x is greater than or equal to, remember the sign said equal to there, so I need to include equal to in my range. And it's also less than or equal to a positive 1. And that's how it looks. That's your final answer. So please guys, do not stop at just the critical values. Critical values just gets you 1 mark, but this gets you your final 1 mark there. Alrighty, let's do another one. This time I'm thinking let's do one where, let's do something like this. Negative x squared less than a negative 4. And yeah, we're asked to solve that, and that's all of it. So what do? I'm going to take my x this side, and if I take it that side, I'm going to be left with the 0 there. It's going to be positive when it gets to that side, and this is how it looks. And this is a difference of 2 squares. It's quite easy to factorize. You open your 2 brackets, x minus 2, and then x plus 2. How am I getting that x minus 2, x plus 2? I just take this guy, square root him. I get an x. I put that x in the first position of both brackets. I take this guy, I square root him. I get a 2. I put that 2 in the second position of both brackets. One is negative and one is positive. So I've done that part. So my critical values are going to be x is equal to a positive 2 for the first bracket, and x is equal to a negative 2 for the second bracket. Alrighty, so we've kind of gotten our critical values. We're halfway there. We need to draw this guy. Right? I need a negative 2 there. I need a positive 2. Please, guys, when you're drawing those, obviously the negatives come first before the positives. So negative 2 would make sense to be this side. Then it would make sense for it to be on that other side, right? So you've kind of done that. And what you can plot is, let's plot this guy here. So that guy there also has a positive A. So if he has a positive A, then he looks like this. Right? And then what does this guy say? He says, when you're looking at it from the perspective of the equation, he's saying the equation is greater than 0. So if the equation is greater than 0, then where am I looking? I'm looking above my x-axis. Remember, if you're reading that guy, if you had it the other way around, it would be x squared minus 4 greater than 0. So this one is telling me I need to look above. So where is above? Above is this range here, which, how do I represent that range? What are these values here? So these values here are values that are less than negative 2. So what does that tell me? It tells me x is less than or equal to negative 2. That's this range, this side. Then we have another range on this side where it's above my x-axis. How do I represent that range? If there was a number here like 3 or a number here like 4, what would be that number? That numbers are numbers greater than 2. So x is greater than or equal to a positive 2. So there is my one range and there is my other range. So these ones are not connected ranges because they're separate. Unlike the two first examples that we did, we'll put those ranges together and x will kind of be in the middle. Right? It will look something like that. So this is when it's for the below part where the ranges are meeting at some point. But if the ranges are not meeting, then this will be the best way to write it as an inequality. All right. I hope that makes sense. Let's do another one. This is going to be our second last example. What if we have negative x squared plus a 5x plus a 6 or less than 0? So at this point, I notice my x squared is negative. I cannot solve a negative x squared. So what I'll do is I'll multiply by a negative 1. I'll multiply everything by negative 1. And if I do that, the x squared will now be positive. The 5 would now be negative. The 6 is now negative. The sign changes direction as well. Anytime you multiply or divide by a negative, this sign always changes direction. So I have the sign changing direction. The 0 will stay as a 0. Then I factorize this guy. And if I factorize factors of negative 6 that add to give me a positive 5, these are my factors. And so my critical values are x is equal to a positive 6 and that x is equal to a negative 1. So these are my critical values. Let's go and plot this. Again, there's your x-axis. We only need the x-axis, guys. We have the negative 1 this side. We have a positive 6 there. Right? But in this case, what was our A? Our A was negative. So what does that tell me? It tells me your graph will be downward facing. So that's how your graph would look, downward facing. Why? Because A is negative, so this will be a sad face. We call this a sad face or grumpy face, right? And then again, I look at this guy here. What does that guy say? It says less than. So less than means below. So below your x-axis, this is the range I'm looking for, and this is the range I'm looking for. How do I write that first one? That first one, x is less than a negative 1. And that second one, x is greater than a positive 6. And that's how you write those two ranges, and these are what we are marking. Right? So that's how you would do it. And then one last question on this. Let's take one where you can't really factorize it. So you do need to use your quadratic formula. So we have this guy. I can already tell there are no factors of negative 2 that would ever give me a negative 3, right? So I'm seeing that A is 1, B is negative 3, and C is negative 2. I use my quadratic formula. Negative B plus minus square root of B squared minus 4AC all divided by 2A. I substitute, I have a negative, -3 plus minus, a -3 squared minus 4, the 1 with the -2 there, all divided by 2, 1. And if I plug this into my calculator, I get these values here. I get 3.56. These are my critical values. And the other one is x is equal to a -0.56. So we've gotten our critical values. What we need to do is we need to plot it. So -0.56 would be there. 3.56 would be there. How does our graph look? It's a positive A, so it's going to be pointing upwards. Smiley face. Right? Positive A, smiley face. So I keep writing this to remind you guys. And then what last thing do we need to look at? We look at the range there. What does it say? It says less than. So less than will be, less than will be between these ranges below our x-axis. So how do I write that guy? That means x will be greater than -0.56, but it's going to be less than 3.56. And there we go. That is our range, and that's how you work with these things. On that note, that's it from my side. These, I wouldn't say they're that difficult. It just needs you to find your critical values. So solve it like a normal quadratic equation you would solve. And then once you have your critical values, you need to interpret what those critical values mean in terms of the graph. You look at the A value and you look at the inequality that's given them. So the A value tells you how the graph looks. The inequality tells you in which side are we looking? Are we looking above the x-axis or are we looking below the x-axis? If it's less than, it means below the x-axis. If it's greater than, it means we are looking above the x-axis. And on that note, that's it from my side. I will see you on the next video. Bye.